Hello Internet, my name is Quentin and this is Blondihacks. I'm working on my locomotive this week, indirectly, because we're getting ready to run this thing on air, but to do that I need a rolling road, which is a way to run the locomotive on the bench. And if you're imagining some sort of Wallace and Gromit-esque contraption, I'm sorry, it's a little simpler than that, but let's go. When you need to test your locomotive, of course, you need to keep it from rolling off the bench while you do that. So one way you might think to do it is to simply lift the wheels off the ground like so. And this kind of works, but it's really not a great idea because similar to testing the drivetrain in a car, you really want the suspension to be fully loaded when testing the drivetrain in a locomotive. It's not as big a deal with this particular model because the suspension on it is extremely primitive. Really the only thing that this suspension does is the front axle can tilt. However, even that is enough to cause issues. For example, this can disguise quartering problems. And I know this because this actually happened to me. When I first quartered these wheels, they seemed okay when suspended in the air like this, but when rolling it on the bench, there was a tight spot. And that was because the quartering error was being compensated by shifting of the front axle when the tight spot was encountered. So I couldn't feel it until I was rolling it on the bench. Many locomotive models have full sprung suspensions front and rear, so then it's even more important because all of the running gear could also have tight spots in it or alignment issues that would be concealed if the suspension was allowed to droop and move under power. The solution then is what's called a rolling road. The traditional implementation of this idea is a set of bearings that can sit under each wheel of the locomotive and allow it to run in place. I ordered 8 bearings for the purpose off McMaster-Carr. They look nice enough, so I'm sure they'll work fine. I also dug around in my scrap bin and I found this ratty old length of 2-inch angle iron, which I think will make nice brackets for holding these bearings in place. I'll cut a bunch of lengths of this off over on the horizontal bandsaw. My overall design here is essentially to make it modular. The bearings will be held by a series of short little pieces that I'm calling bogies, 1 pair for each driver, and they'll be joined together with a plate. And the idea of this is that later on, if I somehow still have motivation to build more locomotives, which I hope I will, I'll be able to add to this rolling road by adding more bogies and just making a new joiner plate. Similarly, if I build locomotives of different gauges or different wheelbases or any other configuration, I can always just reuse the bogies that I have, make a new joiner plate, and Bob's your uncle. The other key to this design is I'm going to make everything adjustable. There are a lot of constraints here, right? There's 8 ball bearings that have to be resting perfectly on 8 positions on the 4 different drivers, and there's a lot of wiggle room in everything. None of these pieces of steel are going to be particularly straight necessarily, so like the old saying goes, if you can't make it perfect, make it adjustable. I'm going to make everything in this whole system as adjustable as is practical to do so. I would like to clean up these pieces a little bit, and actually, a great machine for that would be the shaper. Let's see if I can get some real work out of the new toy. This angle iron is very conveniently sized, but it's like A36 structural steel, so it's got very heavy, nasty mill scale on it. And these pieces are not straight or flat in any particular way, so I want to clean up most of the surfaces on them a little bit, at least where things are going to interface with other parts as needed, or, in areas where it's going to be visible and I want it to look a little nicer. So I'll start by cleaning up the top edge of each of these. That's going to give me a reference edge for subsequent cuts. This is also my first attempt at cutting hot rolled steel on the shaper. Bit of an exercise in learning here. Hot rolled steel does not machine as nicely as cold rolled, and you can really see it on this machine. That surface is okay. I'd call it a 6 out of 10. It's not actually particularly necessary or important that I clean up these surfaces. It's really just an excuse to get some seat time on the shaper, get the feel of it, make some real cuts, try to hit some dimensions, play with the new toy. I must apologize again for the wobbly bench that the shaper is currently on. I've made one attempt to fix that since the last video showing this machine. I blocked up the bench on cribbing so it's not sitting on the casters anymore, and well, it's better, but still pretty wobbly, especially on these close-up shots. So, still working on stabilizing this bench. Apologies once again. Well, the nice thing about the shaper is, although it's slow, you don't really have to babysit it very much. So while that's running, I can do some mock-up with the first couple of pieces, get my dimensions figured out and so on. Gotta figure out roughly where these bearings need to go and roughly how far apart the bogies need to be and so on. Once I have a rough idea where the bogies need to go, I can start to lay out the joiner plate that's going to connect the 4 of them. Found this piece of scrap on the scrap pile for the purpose. I think I can cut a usable piece out of this. Unfortunately, this was an offcut for a reason. It's quite badly warped. I have built a lot of other projects out of what used to be this plate, as you can see, but I've carefully been cutting around all the bent sections of it for all the other projects, and well, now that's come home to roost because I've got nothing left but the bent parts, so I'll have to make them work. I'll take a shot at straightening this plate over on my little 2-ton arbor press. Straightening 1/8-inch steel is a lot to ask of a 2-ton press, but we'll see if we can at least improve it. I do have the press clamped to the bench, by the way, so don't be alarmed as I lean my entire body on this thing. For once, all those cheeseburgers are going to be good for something. I honestly didn't expect this to do a whole lot, but much to my surprise, it actually did. I was able to straighten one of the sections a little bit. So a whole bunch more of that from all different angles and in all different places, and I managed to get it pretty straight. It's not going to win any surface plate awards, but it's certainly flat enough for what we need. The shaper is busy, so I'm going to clean up the edges on this big plate over on the milling machine. I would have had to do this anyway because the shaper only has a 7-inch stroke, so this plate is too big for it. It's actually quite a small machine, that shaper. But that's okay, I have a great setup here that I use for machining the edges of plate and sheet metal. This is a fixture plate that I put in my vise, and then I can use alignment pins in the fixture plate, and the plate sticks off the back of it, which gives me access for side milling. This is a great setup that I really, really like. It's quite efficient for this type of thing. For the most part, shapers are just universally worse than modern vertical mills from an efficiency and versatility standpoint. However, there are a few little tricks they can do that mills still struggle with, and this is one. I want to surface the bottom inside surfaces of these pieces, and the tool post on the shaper can just reach right in there and do it. This would be very difficult on the mill because of the height of the vertical surface. The spindle nose is going to be in the way, so you'd need a very long cutter, like a 2-inch long end mill, and that's not going to be rigid enough to take any kind of decent cut. So it's not often that a shaper can do something that a mill can't, but occasionally they do have their uses. But mostly it's just a toy. Now the surface finish here is definitely pretty poor because I don't have the right tool grind for cutting at this angle. So once that cut was done, I did have to clean it up a bit with a file to make it decent. If I was going to do a lot of that kind of cut, really you'd need to grind a tool that's got the right geometry to be leaned over like that. But I mostly got away with that. After the shaping was done, I took some dimensions on all of these pieces. I wanted to see how the shaper was cutting, and I do actually want all of these pieces to have the same height because it's going to make a future setup easier. I wasn't trying to hit any specific dimension, I just want them all to be the same. And what I found was pretty interesting. The machine had a very consistent taper that it was putting on all the parts. Every single one of these parts is between 3 and 4 thou tapered. So I went and checked the machine to see where that might be coming from. I put a parallel in my vise, and I ran my dial indicator down that. And it's showing 1 thou of taper over 6 inches. And these parts are tapered 3 to 4 thousandths over 3.5 inches. So while there is some taper in the vise setup here, it's not nearly enough to account for the error that I'm seeing in the parts. So it's a bit of a mystery. If you watched my first video on this shaper, then you know that the knee on it is dialed in to within 0.5 thousandths over the entire 9-inch length of it. So the table should be very parallel. However, it's cutting consistently tapered. I took a couple of light cuts and checked again, and the taper was still there, so it wasn't something wrong with the vise setup or the tapping in, something like that. The taper was extremely consistent. I did a lot of messing around with it, and I did eventually find the problem. It was actually in the support foot at the front of the knee. When you raise and lower the knee, that support foot is supposed to move with it. If it doesn't, then the cutting forces of the shaper will tend to push the far end of the table down a little bit, which is exactly what was happening to me. There was actually a tiny little bit of daylight showing under the foot because it was stuck. It hadn't been moving up and down with the knee. So I got it freed up, lowered it back down to where it's supposed to be, locked it down real good. Then I took a series of cleanup cuts on all of the parts to hopefully remove the taper. And I gotta say, even I was pleasantly surprised by this. This is a 65-year-old machine, and that is now cutting straight to within 0.2. So this whole buddy can still make good parts. How about that? I cleaned up all 4 of them and brought them all to the same dimension, and I honestly had no trouble hitting the same dimension on all 4, just the same reading on the tool head hand wheel, and all 4 of them are within a couple of tenths on both taper and dimension. Really, really fantastic. Very pleased with that machine. Pretty impressive for how old it is that it's still making good parts, wobbly bench or no. Even the finish on those is pretty good. Alright, back to those bearings for a minute. Yeah, remember these 8 bearings that I ordered from McMaster? Well, it turns out they are trash. Yeah, all 8 of them are bad. The inner race is malformed on a couple of them, 4 of them are nearly completely seized, and 3 of them sound like 5 clicks of bad road. These things were $15 a piece, which for bearings is still pretty inexpensive, but I don't know, I didn't expect them to be this bad. Honestly, like all 8 of them are just garbage. They're not usable. Now, McMaster is awesome. I sent them an email about the problem, and literally 3 minutes later, they had already issued me the refund. No questions asked. So thanks for that, McMaster, but I do still need bearings. McMaster offered replacements, but I didn't want to wait and risk getting another 8 of these lemons, so I dug through my bin and I found these skateboard bearings, and these are actually really, really nice. And they're actually a better size than the ones I had ordered. Unfortunately, I only have 6 of them, which is super annoying. So I'll mock up with these for now, and I'm going to have to run to town and get some more of these guys. The nice thing about skateboard bearings is they're very easy to get. Every sporting goods store carries them. I lined them up by eye to try and figure out where I want to put them. I want some of the side plate to be proud of the wheel surface because it'll help keep the locomotive from sliding off sideways. It shouldn't anyway because of the taper on the drivers, but just in case, a little insurance there. But I don't want them too low because I want adjustment room as well, and I don't want the sides of the brackets to scrape up the paint on the drivers. So I picked a spot that I thought would satisfy all those constraints and drilled them out. The nice thing about skateboard bearings is they have an 8mm center hole in them, so an 8mm bolt is an easy way to mount them. Now I'm also going to slot out one of each of these pairs of holes vertically so that I can have adjustment of the relationship between the 2 bearings. Like I said, it's not likely I'm going to get the spacing perfect on all 4 of them so that all 8 bearings have perfect contact and equal weight sitting on them for all the drivers. So like I said before, I'm building adjustment into everything just in case. That should be plenty of vertical movement to get the bearings sitting evenly on each driver, I think. Alright, so I've got a pair of them prepared now, 2 of the bogies, and let's see how things are going to work. I've got the adjustable bearing sitting in the middle of each slot, and I want to make sure that things are looking like they're probably going to work before I proceed. And indeed, that looks like that is going to work very nicely. So, one more pair of bogies and the joiner plate, and we should be in business. Now I can set the joiner plate in and get a rough idea of where the mounting holes should go. Again, these mounting holes are going to be adjustable, so I don't have to be very accurate with this. Meanwhile, I ran to town and picked up another set of skateboard bearings, and I thought I was buying the same ones as I did before, but these ones are blue. Why are they blue? Well, because blue is more extreme, I guess. More importantly though, these bearings, also crap. 5 of them are actually fine, 3 of them sound like gravel in a cement mixer. Now, I shouldn't be surprised by this because this entire set of 8 was $15, so it's kind of amazing that you can buy 8 bearings for $15, but I shouldn't expect them to be great, I guess. The previous set of 6 that I bought were from the same store and they were $20, and that's actually kind of amazing. The $15 skateboard bearings are trash, the $20 ones are very nice. So what are skateboard manufacturing companies doing that they manage to get that range of quality within a $5 price point range? Pretty remarkable. But anyway, if you're buying skateboard bearings, which you should, they're great for projects like this, spend the extra $5 and you will be happy that you did. I'm going to keep using these anyway because they'll be good enough for now, and again, because they're skateboard bearings, I can easily replace them at any time. I drilled those holes out way oversized to give myself 2 dimensions of adjustability on all 8 of them. Just want to keep all of my options open for getting everything aligned. Now I need to drill and tap the mounting holes in the bogies, and these need to be at least in the ballpark of those clearance holes to make sure I don't run out of adjustment. So I'm going to mock it all up with the drivers, and a whole bunch of fitlin and fetlin later, I got all 8 of them with apparently equal load on them. All 8 of them are spinning when I spin the locomotive drivers, so they all seem to be sitting nicely. They're all sitting square, everything seems parallel and straight. So this seems to be a configuration that works, and thus I can very carefully now lift the locomotive off of the frames and transfer the first couple of holes. I tried to transfer punch these, but unfortunately I made the really dumb mistake of lining up the bolt holes with the bearings, which made them somewhat inaccessible. So the transfer punching didn't work, and I had to resort to tracing them with Sharpie like some kind of animal. But I used a pin the same size as the circle to line up the Sharpie circles, and again, because everything is super adjustable, this should be close enough. Long reach center drill for the win. I can't even count the number of times that long reach center drills have saved my bacon. These 2 holes were drilled and tapped. I used the DRO and the table slides to make sure that the 2 holes are parallel to the bogey brackets and the exact right distance apart. That initial Sharpie circle was just to get the first hole roughly positioned, so that's why precision was not super important there. Now, with the first 2 bogies marked and drilled and tapped, I mount everything up again and go through that little alignment dance again. I didn't try to transfer all 8 of them all at once because that's a really big source of error when transferring hole patterns. I always do 1 or 2 first, get those bolted firmly in place, then line everything up again, and then do a couple more. Sometimes I'll do the rest of them all at once. But that really increases your success rate on transferring hole patterns by doing 1 or 2 first, then do the rest. Getting these bolts tight was a bit of a fun job because, amazingly, I seem to have lost my 3/16 ball and Allen key. And once again, I very foolishly lined up the bolts with the bearings, rendering them nearly inaccessible. Nevertheless, if I did all that right, then this should now sit on here and should be within adjustment range of perfect running. And I gotta say, that's looking really good. It didn't take much fiddling at all to get all 8 of those bearings apparently evenly loaded. It looks like they are. They're all turning, and everything seems straight. And the locomotive is sitting still and not wandering off, so I think it's okay. Because this whole assembly was built seat of the pants style, I am going to mark all of them so all these pieces go back into their same positions. When you bespoke drill and transfer punch and so on, the parts never repeat from position to position. I also did some filing to clean up the ends of the bogies. Those were still the original horizontal bandsaw cuts, so I made them look a little bit nicer. Then everything got a bath and a degrease to get ready for paint. Since this is all mild steel, I'll give it a nice little paint job and keep it from corroding. I'm a big fan of this instant paint booth. This one is from Wagner, but there's a couple of different companies that sell them. They use a standard furnace filter in the back and a standard household box fan to pull air through the filter, and they catch all of the overspray. So you can spray indoors in your shop like this and not end up with a 30-foot radius covered in little paint spots. If you've been spray painting indoors and you think you're not getting overspray everywhere because you use a cardboard box or you put it on some newspaper or something, you are wrong. You're just not looking close enough. The more you do that indoors, the more everything around you is slowly getting covered in paint. These little paint booths prevent that and are honestly really cheap and a great investment. And they just fold up into almost nothing and are easy to store. So, love this thing. Note that I still wear a respirator when doing this because a furnace filter does not catch volatile organic compounds coming out of the spray can. It's just catching the paint particles themselves. So, the air is still not breathable, but your shop doesn't get covered in paint. This color that I chose is very important because it's the can that I had. Remember how when I got that powder coating set up, I said, I will never spray paint again, powder coating is so much better. Well, this time I thought, the can's sitting right there. I'll just hit it real quick and this will be done. Well, 3 days later, I finally had this painting done. It was a comedy of errors of moving the parts around before they were fully cured and messing up the side I had just painted, and then the paint took longer than I thought it would to cure, and then I had to wait for it to cure again so I could touch up the bad areas, and oh my gosh, it took forever. If I had just powder coated it, I would have been done in an hour. So mark my words, again, when it's my time to go to Valhalla, you will witness me powder coating my mouth silver. Also, remember how these bolts are really difficult to access because they're right below the bearings because I'm a moron? Well, if the automotive industry taught me anything, it's that there is no design problem that can't be solved with an expensive custom tool. I found one of those cheapo Allen keys that come with furniture that you're supposed to use to put together, and I cut the end off of it, and that allowed me to get in underneath the bearings and tighten this all up super easily. So, when it comes time to adjust the bogey positions on your rolling road, go ahead and order Blondihacks' special tool, BH62581. It costs $1,750, and it's only available through our preferred partner service network. Unfortunately, on this final assembly, I found a new problem that I didn't catch in my earlier testing of this design. As I roll it, watch what happens. You see how the locomotive is sliding to the left until it bumps into the bogey on this side? I'll show it to you again. If I push the locomotive over and then roll it a few times, you can see that it's shifting to the left. The conical driver is climbing up the bearing on that side. It's recentering itself. It's doing what conical wheels do. Probably the bearings are a little bit higher on that side. And unfortunately, this is no good because I don't want the drivers rubbing on those bogies. So I studied this for a while and realized all I probably have to do is space the bearings in a little bit, get them close to the insides of the flanges the way the railheads would be on track. And I think that will give me the safety net I need to keep that climbing action from shifting the locomotive sideways into the bogies. With a handful of high-tech shims in the form of garbage washers from my garbage drawer, that has done the trick. Look at that. That is now self-centering and running perfectly straight and solid on there. There's still a little bit of movement in there. The flanges aren't squeezed between the edges of those bearings, but the edges of the bearings are engaging with the flanges as needed to help keep it centered. And that is working really, really nicely. So luckily that was an easy fix. Of course, I had to cut 8 new bolts that were longer to account for those washers. I was also really glad I put that height adjustment on one bearing in each bogie because that was really key to getting approximately equal weight and load on all 8 bearings. Because of the potential for over-constraint here, it's very difficult to get all the bearings perfectly touching the rollers just right. But with that vertical adjustment, I was able to fiddle with it until all 8 of them were running smoothly, and there seems to be at least some load on all 8. I won't claim it's perfectly even all the way around, but it's actually hard to tell right now because the weight balance on the locomotive is really off. Because the boiler is not on it and the cylinders are mounted on the front, it's very front heavy right now. But that does seem to be running really, really nicely. It's tracking straight and it's running smoothly on all 8 bearings. Well, there is my rolling road. I'm very pleased with how that came out. It's a little bit trickier to build than I thought it was going to be. Never having built one of these before, that's how it goes. But I think it is going to work to let us run this thing on the bench on air. That'll be coming soon. Thank you for your patience waiting for that moment. Thank you for watching, and thanks to my patrons for making this happen, and I'll see you next time.